Good evening, my YouTube viewers. In this video, we're going to be covering the Poisson distribution, and we're going to be doing a practice questions regarding a coffee shop. So the practice question is, on average, 50 customers arrive at a coffee shop daily. What is the probability that exactly 55 customers arrive on a particular day? So what we're going to do is we're going to write a program in Python to answer this question, and we're going to import the scipy library to do that. Now, scipy is Python's scientific library, and it has a module in it called stats, and it also has a function that will create the Poisson distribution. So from scipy.stats, we're going to import Poisson. So we're going to set the parameters for the Poisson distribution. So lambda underscore equals 50. That's the average number of customers arriving per day. And the number of customers that we are interested in is 55. So we're going to calculate the probability of exactly K arrivals, or 55 arrivals. Probability equals Poisson.PMF, and that's probability mass function, brackets K equals 55, comma, lambda underscore equals 50. And then we're going to print the probability that exactly 55 customers arrive at the coffee shop in a day is approximately 4.22%. because they have an average of 50 customers, and you want to see if 55 are going to arrive. So now we have another question. What is the probability that fewer than 45 customers arrive in a day? So we're going to import scipy. So from scipy.stats, we're going to import Poisson, and we're going to set our parameters for the Poisson distribution. Lambda underscore equals 50. So that's the average number of customers arriving in a day. And K is 45. So you want to see if there's fewer than 45 customers in a day. So we're going to calculate the cumulative probability for X is less than or equal to 44. So probability fewer than 45 equals Poisson.CDF, that's cumulative distribution function, brackets K minus 1, so that's 44, comma, lambda underscore. So we're going to print the probability that fewer than 45 customers arrive in a day is approximately 22.1%. So now we have another question concerning the survival function. So in this particular question, we're going to be using the survival function. But what I want to do is I want to use the other formula as well, just to prove to you that there's two ways that you can print the survival function. I mean, the most logical way to present the survival function is to actually use scipy's survival function. But if you're using something like Excel, and Excel doesn't have a survival function, then you're going to do 1 minus CDF. So that's what we're going to do. So we're going to import scipy.stats and import Poisson from that. And we're going to set our parameters for the Poisson distribution. So lambda equals 50 and K equals 60. So you're looking for at least 60 customers in a day. I'm just going to run this program again. And then we're going to calculate probability. At least 60 equals Poisson.SF, brackets K equals 60, comma, lambda underscore equals 50. And then we're going to use the other algorithm as well. So prob at least 60 equals 1 minus Poisson.cdf brackets k equals 60, comma, lambda underscore equals 50. And then we're going to print the probability that at least 60 customers arrive in a day is approximately 7.22%. And we use the other formula as well of 1 minus CDF, and that's 7.22 as well. So you've got two ways that you can calculate the survival function. And obviously, the most common sense way is to use the SF because that is your survival function. But if you happen to be using Excel, then you would need to use 1 minus CDF because I don't think Excel has a survival function. So that concludes this video. The next video is going to be on defective parts, so I hope that you decide to watch it.